In this module, we will cover three things. Of course, first is the introduction, and then the lecture proper will cover two areas. You have the sampling distribution and estimation. First lesson under sampling distribution will cover the sampling distribution of the mean. There are three objectives of this lesson. First is to clarify the basic concepts of the sampling procedure. Second, we will distinguish the statistic and the parameter. I mentioned this earlier in the introduction. And third, we will be constructing the sampling distribution of the mean. Okay, let's again refresh our memory with the basic concepts of descriptive and inferential statistics. So as earlier mentioned, we have the sample and we have the population. So in the statistics, when studying the entire population is not possible or it's not practical, we are allowed to study a subset or a subgroup of the population. This subset of the population is what we call as sample. The process of selecting the members of your sample is called the sampling process. Of course, in your earlier lessons in statistics, there are ways of doing the sampling process, like you can do a systematic random sampling, the simple random sampling, and so many other ways of or techniques of selecting your sample elements. But these are beyond actually the coverage of this lesson. We will focus more on describing the variations of computed values in the mean. But first, let us clarify the issue of the sampling size. There is actually a method of computing for the ideal sample size given or known the population size. We have what we call the Slovene Formula. Again, we call it the Slovene Formula. If this is your first time to hear this concept, the formula is given as small n is equal to the ratio or the quotient capital N over 1 plus the product n multiplied by a squared. So what are these? Well, the small n is actually the sample size. The capital N is the population size. So you know your population size. It's the capital N. What we want to compute is the sample size, which is in this case, it's the small n. Then there is what we call the margin of error. It's denoted E in this case. That's exactly what you hear in the surveys. Usually they mention about a margin of error ranging from 3% to 6%. And that's the standard value of the margin of error. Usually it's 3% up to 6%. So all you need to do is to supply this information in the formula. As you know, as I mentioned, it is n over 1 plus ne squared. By the way, the formula is just a guide for us to come up with a proper representation of the population. Actually, the number that you will obtain here is the least value. So there's no problem if you go beyond the value. What is important here is you do not go lesser than the computed size of your sample, that is small n. Okay, let's go back to the issues of the surveys that we mentioned in the introduction. Let's just assume that the population of country is 80 million. Well, as I said, there are roughly 106 million now at present, but let us exclude those who are under 18 years old. So what we consider are those 18 years old and above. So roughly there are about 80 million of them. So what's the ideal size of a sample when we conduct surveys? Well, we will use the Slovene formula. So in the formula, capital N is actually 80 million. And then what we want is the small n. What's the margin of error? Okay, let's first apply a 5% margin of error. So, bring out your calculator, compute. So it's going to be 8 million over 1 plus 8 million multiplied by 0.05 squared. Okay. Calculator, what do you get? That is roughly 400. That is roughly 400. So in other words, for a 5% margin of error, you need only 400 respondents to represent around 80 million individuals. So, if you look at the surveys now, they are even way above the required number. Let's try another margin of error. Suppose it's 3%. If we assign a 3% margin of error, okay, compute it again. 8 million over 1 plus 8 million multiplied by 0.03 squared. What do you get? Okay, so that's around 1,112 respondents. So we can actually say that these surveys are maybe using a 3% margin of error, and they even exceeded the minimum number of respondents, that is 1,112. They are using 1,200, 1,500, or even 1,800 respondents. So there's no question actually of the sample size now. They have enough representation, or they have enough respondents as to the required sample size. Of course, as I mentioned in the introduction, there are other issues that we need to address when it comes to data gathering. Sample size is just one of them. What's the other? Do you still remember? What's the other issue that we have to address? Of course, that's the sampling procedure. The sampling procedure. How do we select the elements of your sample? Okay, we have the number, okay? We have the number. We have 1,200, 1,500, 1,800. All these numbers are valid to use to represent 80 million. But how are we going to select these respondents? So that's the other issue that we are going to address here. Of course, again, if you recall what you learn in statistics, there are certain processes or techniques of selecting your samples, like the simple random sample, where you need to randomly select the elements. Usually, according to the survey firms, they randomly choose telephone numbers, and then they will call, and then they will conduct a face-to-face interview. Well, let's just trust on what they claim. And then they do face-to-face, they do interviews, and so on. So perhaps they are able to settle the issue of the sampling process. Okay, so assuming now, okay, we are assuming that we have the sample size enough, and then the sampling process is valid. Now we will do the characterization of the sample. So we are going to compute certain values in the sample, like what is the mean, what is the variance, and then use this information to characterize the entire population. Remember, when these survey firms reveal their results, they don't mention that they only use 1,200 or they only use 1,500 respondents. They will just say Filipinos have this opinion, or the Filipinos in general have this sentiment. So they will never mention about the sample size anymore. They will just use the information to characterize the entire population. That's what we are going to focus on. When can we say that the value or the characteristic that we obtain in the sample is valid to characterize the entire population? We need to put everything in correct perspective at this point. In probability, we usually define what we call a random variable. So we conduct a random experiment. Once you have a random experiment, you can now define what we call a variable, a random variable. Once you are able to define that, you proceed with computations like what's the distribution or the probability distribution of this variable, and then what's the expected value of this variable, what is the variance of this random variable. So when we consider a statistic, I mean a value that is computed in the sample, we expect this to vary from sample to sample. So it's valid to say that, for example, in the case of the sample mean, we can treat it as a random variable. So we have a random variable corresponding to the mean of the sample group. So we expect this to vary from sample to sample. Okay, so again, to summarize things that I have mentioned so far, we have a random variable corresponding to the mean of the sample group. So what we will do now is to construct, as usual, once you have a random variable, the immediate action that you need to do is construct the corresponding probability distribution. When you say probability distribution, we're going to determine the probability that its value of your random variable will get this specific value all throughout the possible experiments or replications of your experiments. For example, in a class of 40 students, you can only select, for example, 10 per group, or per each group. It will consist of 10 students. So at one point, you have a different composition of the sample, and in another group, there's a different composition. Of course, there will be a different value of mean here, and then there will be a different value of mean in the other group. That's basically what we are trying to convey here, that the value will change from sample to sample. That's why we call it a random variable also. So the sample mean will also be a random variable. To specifically illustrate this, let's consider 5 friends, namely JC, Jake, Dexter, Prince, and Dawn. And we measure their weights, let's say in terms of pounds, and then we select we select groups with 3 members each. So for example, we can select JC, Jake, and Dexter together. And then in another group, we have Dawn, Dexter, and Jake, and then so on. That's what we're going to do. Out of 5 people, we're going to form 3 groups. We're going to form groups with 3 members each. How many possible? First thing is, how many possible groupings can we have? Any idea? Remember, we are going to select 3 individuals from available 5 individuals. How many ways can we select a group with 3 members? Well, you can play with the names. You have only 5 names available now, and you can play with the names. You can segregate them 3 at a time and so on. But well, in statistics we also covered what we call the counting principle. So if you recall your counting principle, to be able to form or to be able to select 3 individuals out of 5, that is just the combination counting. In combination, we have the 5 people available, and then we want 3 individuals to compose your sample. So it's going to be 5 taken 3, or that's the combination of 5 taken 3 at a time. That's easy to see in your calculator. So if you have your calculator with you, just press 5 and then the combination key and then 3. Do that. 5 combination 3. How many possible groups do you have? Correct, it's 10. So there are supposed to be 10 possible sample groups. Now when we conduct research, only 1 will be chosen. Out of these 10 possible groupings, only 1 will be chosen. And so if you're going to be precise in the characterization of the sample, we employ what we call the randomness of the selection. So the issue of randomness somehow will settle issues of bias in the selection process, in getting your samples. Anyway, we go back to our grouping. So we said that out of these 5 friends, we can form 10 possible groupings with 3 members each. Okay, so I did the work for you. I have the listings now. I have the listing of the groupings, as you can see here. These are the 10 possible groups. Like in one group, you have JC, Jake, and Dex going together, and then another you have JC, Jake, and Don. So you can vary the members of this, and as you can see, there are 10 possible groupings. And then from this, we also get their weights. The weights are measured in pounds. So in the second column, actually, you get the values. What we want to do here is to measure the average weight in its group. So, which means that since there are 10 sample groups, we will have to compute 10 different means. We have JC, Jake, and Prince with weights 52 pounds, 60 pounds, and 48 pounds. We have to determine the mean. Of course, the mean is an easy story to you now. How do you get the mean? Well, get the sum of the 3 weights and then divide it by 3. So, for example, in the first group or in the group of JC, Jake, and Prince, what's the mean? What's the mean weight? Okay, that's going to be 53.3 pounds. So, in the first sample group, the mean is 53.3 pounds. Now, if you look at the second group, okay, if you look at the second group consisting of JC, Jake, and Dex this time, okay, again, JC, Jake, and Dex, their weights are 52 pounds, 60 pounds, and 50 pounds. The average, in this case, is going to be 54 pounds. So, there's another value of the mean now. It's going to be 54. So I leave to you for the remaining 8 groups. Bring out your calculator, compute for the means. And just fill out or provide the values in the third column of the table that I have shown you earlier. Okay? Just I'll give you around 3 minutes to complete the table. Supply the means of the 8 remaining groups. Okay, so I hope we all agree on the averages that we compute in the 10 different sample groups. Let's just recap. For the first group, we have 53.3 pounds. For the second group, you have 54 pounds as average. And then you have 2 common values for the third and fourth. These are all these are both 50 pounds. And then you have 46 pounds, 46.7 pounds, 52.7 pounds, 48.7 pounds, 49.3 pounds, and then the last group will have 45.3 pounds. All agree? Very good. So, based on this tabulated means, our random variable corresponding to the mean of the samples will have 9 possible values. Why 9? Well, of course, because 50 was repeated. Okay? 50 was repeated. So you don't need to specify 50 twice. So again, let's go back. Our random variable is, let's just put it in a symbol, like X bar. Okay, so our random variable is X bar, corresponding to the mean of a sample. And this X bar will have 9 possible values. What are these 9? Of course, as I mentioned, you have 53.3, you have 54, you have 50. Of course, 50 will be counted once only, although it appeared twice. And then you can run the other values. There are 9 possible values. So remember, when you tabulate your probability distribution, it will be on the first row. So your first row with a label X bar, that's the random variable, you have the 9 possible values. Okay? So that's the first row of your probability distribution. On the second row of your probability distribution will be the possible probabilities of each sample mean. For example, the first mean was 53.3. So how many 53.3 did we have? It's only one. There is only one occurrence of 53.3 coming from the first group. So when you assign or when you compute for the corresponding probability in your probability distribution, it's going to be 1 over 10. Is that clear? It's 1 over 10 because there is only one group that yielded 53.3 out of 10 possible sample groups. So if you look at the table now, the first entry in the sampling distribution in second row is 1 over 10. But the first value of x bar is 53.3 and the probability is 1 over 10. Okay, let's look at the value x bar is equal to 50. X bar is equal to 50. If you look at your sample groups, there are 2 sample groups that yielded this mean. So when you compute for the probability, then it's going to be 2 over 10. Well, that can be reduced to 1 over 5. So in the table, in the table that we are constructing at this point, we will enter the probability 1 over 5 corresponding to x bar equal to 50. Well, of course, you can already predict that the rest of the values in your x bar will have a probability of 1 over 10 because its value occurred only once in a sample group. So if you complete the probability distribution of x bar in this example, it's going to be 1 over 10, and the first value it's 1 over 10. 1 over 10 on the second value, and then 1 over 5 in the third value, and then all the rest will have 1 over 10. So your second row in your probability distribution will have these values: 1 over 10, 1 over 10, 1 over 5, 1 over 10, and so on. Now remember, in our discussion of probability distribution, to check whether you have a valid probability distribution or not, we have to sum or we have to check the sum of the probabilities. And according to the rule, it must be equal to 1. Well, that's easy to see in our constructed probability distribution now. If you add all the fractions in the second row, it is 1 over 10 plus 1 over 10 plus 1 over 5 plus 1 over 10 and so on. What do you get? Simple algebra, that is going to be 10 over 10. And 10 over 10 is equal to 1. That simply means that we have a valid probability distribution. Now, so we have this table. We have the table corresponding to the first row is the values of are the values of your random variable. Our random variable again are the values of the means. And the second row are the associated probabilities for each value of your random variable. So the completed table is what we call the probability distribution of the sample mean. Roughly or technically, this is now the sampling distribution of the mean. Again, this is what we call the sampling distribution of the mean. So it's basically the same as the probability distribution that we discussed in random variables, but this time we are focusing on how this random variable varies from sample to sample. That's why we call it the sampling distribution of the mean. Well, we just removed the probability. It should be called actually the probability distribution of the sample mean. But we cut it short, we call it the sampling distribution of the sample mean. So let's look at another example. Victor wanted to examine how his friends respond to his Facebook post in 5 days. So he observed the number of likes that his friends made on this particular Facebook post, and the data is shown in this table. So we have the Monday, Tuesday, Wednesday, Thursday, Friday data. So correspondingly, you have 68 likes on Monday, you have 65 likes on Tuesday, and then you have another 65 days on Wednesday, and so on. So as you can see in this table, you have a summary of the number of likes made by his friends on this Facebook post. Now, we would like to examine the probability distribution of the average number of likes when we randomly select 3 days only. So again, we'd like to examine the sampling distribution of the average number of likes when 3 randomly selected days are chosen out of the 5 days, Mondays to Friday. So the selection will just be Monday, Tuesday, Wednesday, Monday, Wednesday, Friday, Monday, Tuesday, Thursday, or maybe Wednesday, Thursday, Friday. So these are the possible groupings now of your sample of days. Like what we had in the first example, it's just a matter now of determining the combination of 5 days taken 3 days at a time. So it's going to be, again, you can bring out your calculator, just press the combination key, 5 taken 3 at a time. So of course, this is just similar to what we had in the first example. 5 taken 3 is just going to be 10. So there are 10 possible combinations of 3 days, okay, in a group. So as I mentioned, you can have Monday, Wednesday, Friday, or Monday, Tuesday, Wednesday, and so on. So we tally the number of likes for each of these days in this sample of 3 days. So again, you can summarize the sample groups. This time our sample elements will be the days. So you have a summary of the sample groups, just like what we did in the names a while ago, but this time it will be according to the days. So we have the 10 groups of 3 days each group. Okay, so we are talking about the average here. So just what we did in the first example, what will be our next move? Of course, we're going to compute for the mean on each group. So again, bring out your calculator, compute for the mean for each group. So for example, in the first group, you have the number of likes as indicated, and then you get the average. Okay? So I'll give you some minutes to complete the last column of this table corresponding to the means or the average number of likes for each group or for each group of 3 days. Okay, so I'll ask you now, how many possible values of x, how many possible values of the random variable can we have? Remember, in the first example, when we computed for the mean, we came up with 9 possible values of the random variable x bar. But in this particular case, I'll ask you now, how many possible values of x bar can we have out of the 10 groups that we have so far? In this case, or in this example, we'll only have 7. Again, we'll only have 7 values of the random variable x bar. What are they? Well, you must have 66. You have 66? Very good. And then you'll have 66.7. You'll also have 66.3. Okay? And then you have 65.7, 65.3, and so on. So, once you have this enumeration of the 7 possible values of x, so we next construct the probability distribution of x bar. So similar to what we did in the first example, we have another table to construct. The first row will be the numbers or the computed means of each group. So you have 66, 65, 65.3, and so on. So you list down the computed means in the first row of your probability distribution. So if you feel or if you provide the values in your first row in the probability distribution, the first value is 65.3. Let's just arrange the possible values in ascending order from lowest to highest. So the first value is going to be 65.3, correct? And then the second will be 65.7. And then you'll have 66, you'll have 66.3, and then you'll have 66.7, and finally 67. Those are the 7 values of the random variable. Now, we fill up the probabilities. So question is, what is the associated probability when x bar is equal to 65.3? How do we determine that again? Well, go back to your sample group. Out of the 10 sample groups, how many groups yielded an average of 65.3? Well, as you saw, there is only one group. So the probability will be 1 over 10. Okay, so that's correct. The probability for x bar equal to 65.3 will be 1 over 10. For the next value, that is 65.7, it will also be 1 over 10 because there is also one group yielding an average of 65.7 likes. And then you have 66. How many groups yielded an average of 66? There are 3. So the probability is going to be 3 over 10. And then you have 66.3. That will be 2 over 10. 66.7, also 2 over 10. And then the last value, 67, will also be 1 over 10. And you can easily check. If you sum all these probabilities, so far you have 1 over 10, 1 over 10, 3 over 10, 2 over 10, 2 over 10, and then 1 over 10. If you sum all this, you'll get 10 over 10, or that is equal to 1. So we have a valid probability distribution. So this is the sampling distribution of the average number of likes that Victor earned from his Facebook post. Okay, so I hope with these 2 examples or with these 2 illustrations, you're able to gain information as to how to construct the probability distribution, or what we call the sampling distribution of the mean. Just to summarize, okay? Just to summarize, first step, of course, is to determine the groupings of your samples. And then, second, you compute for the mean on each sample group. And then, construct the sampling distribution using a tabular form. The first row of the table will be the values of your x bar. Okay? And then, the second row in your table will be the associated probability. So, for each value of x bar, there should be a corresponding probability. So, once you have completed the entries in your table, then that's basically what we call the sampling distribution of the mean. It's that easy. Okay? So the next lesson now will be, if you recall, in your discussion or in your lesson on random variables, we don't just end with the probability distribution. There are succeeding computations that we need to perform to be able to characterize the population of interest. So after constructing the probability distribution, or after constructing the sampling distribution of a certain statistic, our next concern is to find the average or the expected value of this random variable. I hope you will be able to recall at this point how to compute for the expected value for a particular random variable. Well, anyway, we'll review that in the next lesson.